Equations and their solutions. In this video, you'll learn how to explain what it means for a value or pair of values to be a solution to an equation. You'll also learn how to find solutions to equations by reasoning about a situation or by using algebra. Let's start by looking at equations in one variable. An equation in one variable contains only one unknown value or number that can change, such as 2x plus 1 equals 6, or 4 minus y equals 1, or a equals 4 times 5, since all of these equations only have one variable. Solving these equations means finding the only value that will make the equation true. So let's look at some examples of these equations in one variable. A rectangle has a perimeter of 72 units and a length of 15 units. What is the width? So we know we have a rectangle with a length of 15, but we don't know the width, so we'll just leave this W for now. And we know that we can find the perimeter of a rectangle by adding twice its length and twice its width. Since we know that the length is 15, we can replace L with 15 in our problem. The example told us that the perimeter of the rectangle would be 72 units. So we can replace the perimeter with 72, and now we have an equation that only has one variable, so we can solve for W. We'll start by simplifying. 2 times 15 will give us 30. Now we can start solving for W by subtracting 30 on both sides. This gives us 42 is equal to 2W. Now we'll divide both sides by 2. So we get W equals 21. So now we know our width was 21 units. Now let's look at equations in two variables. An equation in two variables contains two unknown values or numbers that can change. For example, 2x plus y equals 7, or a minus b equals 5, or L times W equals 50, since all of these equations have two variables in them. Solving these equations means finding a pair of values that make the equation true, instead of just one value. So let's look at some examples of two variable equations. Tyler spends $45 on socks and t-shirts. Each t-shirt is $10 and a pair of socks are $2.50. How many of each can he buy for exactly $45? We'll start by writing down what we know. We know that each t-shirt is $10. So we can represent this as 10t, since we can multiply every t-shirt by $10. We also know that a pair of socks are $2.50. So we can add 250 times S to represent the total cost of buying socks and t-shirts. Since we know he wants to spend exactly $45, we'll set our equation equal to 45. One solution that might work is 3 t-shirts and 6 pairs of socks. Since if we replace t with 3 and s with 6, we'll get 30 by multiplying 10 times 3, and 15 by multiplying 250 times 6. And adding these will give us exactly $45 that he wanted to spend. Another solution that would work are 4 t-shirts and 2 pairs of socks. Because if we replace t with 4 and s with 2, we'll get 40 plus 5 will give us exactly 45. So when we have an equation in two variables, there will be more than just one answer that will work. We'll have an infinite number of pairs that will work for our situation. A vendor is selling handmade candles and soaps. Candles are $2.25 each, and soaps are $1.50 each. Which combinations of candles and soaps can the vendor sell for exactly $12? And here are the options we have to choose from. So we'll go through each solution and see if it will give us exactly $12. First, we need to make an equation for this story, though. We know that candles are $2.25 each. So we can represent this as 225C. And we know that soaps are $1.50 each. So we can represent this as 150S. Since we know we want them to sell for exactly $12, we'll set our equation equal to 12. Now let's go through our options and see which ones will give us exactly $12. We'll start with 5 candles and 1 soap. So we'll replace C with 5 and S with 1. Now we can evaluate to see if we get $12. 225 times 5 gives us $11.25, and $1.50 times 1 is still just $1.50. Adding these together gives us $12.75. So this is a little bigger than the $12 that we wanted. so this won't be a solution. Let's try our next option at 2 candles and 5 soaps. So we'll replace C with 2 and S with 5. Multiplying gives us 450 and 750. When we add these together, we get exactly $12. So this is one possible solution. Now let's look at selling 3 candles and 3 soaps. C will become 3, and S will become 3 as well. Multiplying gives us 675 and 450. So when we add these together, we get 1125, which is not the 12 that we wanted. So this is not a solution. Now let's try our last option with 4 candles and 2 soaps. We'll replace C with 4, and S will become 2. Multiplying 225 and 4 gives us 9, and $1.50 times 2 gives us 3. So when we add these together, we get the 12 that we wanted. So this is also a possible solution. Here's another one. Callie is collecting dimes and nickels in a jar. He has collected $5 so far. The relationship of the coins he collected can be represented by the equation 0.10d plus 0.05n equals 5. We'll go through all of our options to see if there are solutions to Callie's equation, to see if they'll give us exactly $5. Let's start by bringing down the equation they gave us. 2060 represents 20 dimes and 60 nickels, so we'll replace D with 20 and N with 60. When we multiply, we get 2 and 3, so when we add these together, we get the $5 that we wanted. So this is a solution. Let's look at the next one with 25 dimes and 40 nickels. So D becomes 25 and N becomes 40. Multiplying will give us 2.5 and 2. When we add these together, we get 4.5 and not the 5 that we wanted. So this is not one of our solutions. Now let's look at 25 dimes and 50 nickels. D becomes 25 and N becomes 50. Multiplying gives us 2.5 and 2.5 again. So when we add them, we get the 5 that we wanted, so this is also a solution. Now let's try our last option of 35 dimes and 40 nickels. D becomes 35 and N becomes 40. Multiplying gives us 3.5 and 2. So when we add these together, we get 5.5 and not the 5 that we wanted. So this will not be a solution. Here's one last example. Volunteer drivers are needed to bring 60 students to the championship baseball game. Drivers either have cars that can seat 4 students or vans that can seat 6 students. The equation 4c plus 6v equals 60 can be used to describe this situation. So I'm going to pull up a couple statements and we're going to decide if they're true or false. If 12 cars go, then 3 vans are needed. Let's start by taking the equation they gave us. And we'll replace C with 12, since we know that 12 cars are going. And V will become 3, since 3 vans are going. 4 times 12 gives us 48, and 6 times 3 gives us 18. Adding these gives us 66, so we were able to transport 66 students when we only needed to transport 60. So we actually could have just taken 2 vans instead of 3, instead of having 6 extra seats. So this is a false statement since we needed 2 vans and not 3. Now we have that a pair of C equals 6 and V equals 6 is a solution. So we'll take our equation and replace C with 6 and V with 6. 4 times 6 is 24, and 6 times 6 is 36. Adding 24 and 36 gives us 60, which is what the equation said it should equal. So this is a true statement. Now we have that if 5 cars go and 7 vans go, there will be extra space. So we'll put these values into our equation, and when we evaluate it, we'll want our number to be bigger than 60 to show that there will be extra space. So we'll start by replacing C with 5 and V with 7. This gives us 20 plus 42, which gives us 62. So we have 2 extra seats, so this is a true statement. Now we have that if 8 cars go and 5 vans go, then there isn't enough to transport all of the students. So we'll put this into our equation, and we'll want to see a number less than 60 to show that we didn't have enough room. So C becomes 8, and V becomes 5. This will give us 32 plus 30, which gives us 62. So we actually have extra space instead of not enough. So this is a false statement. Our last one says that if 15 cars go, then no vans are needed. So we'll take our equation and replace C with 15 and V with 0, since no vans are going. This will give us 60, and we can see that this is already enough. 4 times 15 provides 60 seats, so no vans are needed. So this was a true statement. Now let's summarize what we've learned. One variable equations have only one unknown or changing value. So this means they'll only have one solution. Two variable equations will have two unknown or changing values. So these will have pairs of solutions, and not just one. We'll have an infinite amount of pairs that will satisfy a two-variable equation.